Hi, my name is Judy, and for my grade 12 chemistry summative, I'll be talking about the application of chemistry in blood. So blood is a bodily fluid that transports nutrients and wastes to and from body cells. It is composed of liquid called plasma that contains proteins, glucose, mineral ions, hormones, and carbon dioxide. Platelets and red and white blood cells also is part of the composition of blood. Now, the application of chemistry in blood is mainly of equilibrium, and therefore the connections to the course can be found in chapters 7, 8, and 9. In chapter 7, equilibrium, we learn that it occurs when opposing changes are occurring simultaneously at the same rate. The Le Chatelier's principle, a dynamic equilibrium tends to respond so as to relieve the effect of any change in conditions that affect the equilibrium. It can be used to explain how oxygen is transported, the buffering in blood, and carbon monoxide poisoning in the blood. So in oxygen transport, the equation of oxygen by hemoglobin can be seen here. In the lungs, where there is a high concentration of oxygen, the equilibrium position shifts to the right, resulting in oxyhemoglobin. And the oxyhemoglobin is transported around the body by blood, and as it reaches the tissues, the concentration of oxygen is lower there, therefore the equilibrium shifts to the left, and oxygen is released and absorbed by the cells. In the buffering in blood, hemoglobin is involved in a series of reactions that result in this equation right here. Now, due to metabolic reactions, several acids form, increasing the concentration of hydronium ions, and this lowers the pH and forces the equilibrium to shift to the left, and this reduces the supply of oxygen to the cells. And in order to combat against this, buffers are used in the blood system, and this will be explained further on. In carbon monoxide poisoning, the equation for carbon monoxide that reacts with hemoglobin is written right here. The equilibrium constant for carbon monoxide is greater than that of oxygen, and therefore it reacts more readily with hemoglobin and less is able to transport oxygen to cells. And these tissues end up starving of oxygen and the organism dies. In chapter 8, we talked about acids and bases. And in blood, as previously mentioned, buffers are used in order to balance the pH. Buffers reduce the change of pH in a solution even when acid or base is added. Buffer solutions contain a weak acid and its conjugate base, or a weak base and its conjugate acids. There are 3 different types of buffer systems in the blood. There is the phosphate buffer, which the equation is written on there, and the protein buffers, that are protein containing the carbonyl COOH group and the amide NH2 group. However, the main buffer used in the blood system is the bicarbonate buffer. In bicarbonate buffers, dissolved carbon dioxide reacts with water to form hydrogen carbonate ions. Now, this is used when hydronium ions are added into the blood by metabolic reactions, and it combines with bicarbonate to create carbon dioxide and water. And if excess hydroxide enters the blood, it is also removed by combining with bicarbonate to create carbon dioxide and water. In chapter 9, we talked about aqueous solutions and solubility equilibrium, and this blood can be a link to the formation of precipitate. So solubility constant is proportional to the concentration of solid that is allowed to be dissolved to create a saturated solution. The solubility constant is Ksp, and the ion product is Qsp, and the expression is calculated by using concentrations, not those at equilibrium. In aqueous solutions, if the ion product is larger than the solubility product, the formation of precipitate will occur. In blood, kidneys control the concentration of ions in the blood and balance equilibrium. An example would be calcium plus phosphate creating calcium phosphate. Now, this equilibrium causes the formation of kidney stones or the disease osteoporosis. If the kidneys remove too much calcium in the blood, while the calcium is in the kidneys, the reaction shifts to the right, forming calcium phosphate, which forms a precipitate called kidney stones. And as calcium phosphate gives bones their rigidity, if kidneys remove too many phosphate ions due to maybe the effects of a disease, the reaction shifts left, and thereby reducing bone density, and the loss of too much calcium phosphate leads to osteoporosis. And that is the end of my presentation.